Okay, are we live? Hello? Hello. So, back. Took a short break, kind of just hung out for a few minutes. Hopefully everything is in good shape. We're gonna move on to another question. We were looking at a question previously. Excuse me, and I think it's time for me to look at move on to another question. So, let me do a couple things before we get going. So hello and welcome, and normal. Now what I realized, I kind of like to listen to music when I'm on my computer, so I'm going to mute the desktop audio, and that way I can listen to music, and it won't be too. It might be kind of distracting, but it won't show up on the audio for those listening. So yeah, I really like this. It's a good song. Holding on to hope without assurance, holding on to a memory of light, a morning come. We'll never see the sun, and never will find the long defeat. Wiggle sequence is a sequence where the differences between successive numbers strictly alternate between positive and negative. The first difference, if one exists, may be either positive or negative. A sequence with two or fewer elements is trivially a wiggle sequence. For example, 174925 is a wiggle sequence because the difference is 6, -3, 5, -7, 3 alternate between positive and negative. In contrast, 15725 and 17455 are not wiggle sequences. The first is not because its first two differences are positive, and the second is not because its last difference is 0. We'll find the long defeat. 6, -3, 1, 0. Oh, so if there's any zeros in there, then it's not a wiggle sequence. Okay. A subsequence is obtained by deleting some elements, possibly 0, from the original sequence, leaving the remaining elements in the original order. Given an integer array nums, return the length of the longest wiggle subsequence of nums. Oof. Okay. Got all these wiggle sequences, man. The wiggle. There's like wiggle sort and wiggle sequences and wiggle sort 2 and all these things. Oops. All right. Also, you're gonna notice me every 5 minutes switching songs to something that I don't want to listen to. And then waiting 5 seconds for the ad. Let's see. Can you solve this in linear time? I think you can. I seem to know. There's blood on the sand, and there's a gun in the streets, and there's a gun in my hand, and there might as well be an Savior friend. So sick of it. I think you do linear time, linear space. So you can store the differences in an array. You can store the differences in an array, and then basically you're looking for the longest alternating subsequence, positive and negative numbers in that array. Which I don't think is that hard to do, actually. just think about how you might be able to do it. So let's say we could do two different ways, or one way of doing it is sec of it. So at each index, you could say, what's the longest possible subsequence that contains that index, right? And then the longest possible subsequence has to contain at least one of these indices. So that's kind of what you do for the largest consecutive sum, I think it's called, or the largest subsequence sum, just kind of sort of a classic problem. Gun in my hand and it might as well be in the sack of it. Yeah. So well, you could do that. You could do it in quadratic time by finding the longest possible subsequence that contains that particular index for each index, right? And you could do that as kind of a loop for each index, and then at the end you would loop over all of the results and take the largest value at the end of it. The length is what you're looking for, so the largest length. But you could probably do this linear time by kind of keeping information as you go from step to step. So sympathetic hearts of oath, sworn oath. Probably shouldn't be listening to music while I'm thinking about this. I'll just put on music if I feel it. If I'm feeling kind of low. I want to wait a second. I think I shouldn't listen to music until I get stuck. If I get stuck, then I could put on music and just kind of forget about what's going on. But if I'm not stuck, then I don't think I should do that. So, because I should really focus on the problem. Because I'm not really stuck on this problem, but I am like going a lot slower because I'm singing through the songs, which is not ideal. So yeah, so I think there's a way to do this that's similar to what I was describing, and I think you can make it linear by like using more information at each step, like using previous information. So you'd have like at index I, there's no sequence because basically, like by definition, it has to have at least more than one element, right? A sequence of two or fewer is trivially okay. Fine. So by definition, two or fewer, even if there's a zero, which is kind of interesting. Is that true? Wait, hold on. Let me just see. Something. What is their definition? This is something you might like ask the interviewer, like, what about these cases? What do you expect? Okay, there's got to be at least one. So those are just thrown out. What about these three cases? Expected is 1, 2, 1. 1, 2, 1. Oh, interesting. So no. Not true. Two or fewer is not trivially a Wiggle sequence. False. Right, if it's a 0, then it doesn't count. But if it's one element, it does count. So really the minimum is going to be at least a 1. So that's good to know. That'll handle those kinds of edge cases, or somewhat handle those edge cases. So, okay, so if our difference set, so if you have a 0 in the sequence, I think it kind of just dies in the water, just by the way, because you're supposed to be alternating between positive and negative. Okay, so here we say, all right, we have a 1. There's just one element in this sequence. It's a subsequence. Yeah, it's not a consecutive subsequence, which is kind of interesting. So being that it's not a consecutive subsequence, I actually think this is a lot easier than I'm making it out to be. I don't think you need to do dynamic programming or get fancy or really think too hard about this, because it's not a consecutive subsequence, which really just means that you're going to just pair off positive and negative numbers. So really you're just going to count the number of positive and negative. Now you do need an order on those positive and negative numbers though. So maybe it is a little bit more involved in that. I take it back. Even though it's a subsequence, it's not. So I guess you might want to use like a stack then. Yeah, you just push, as you go left to right, you push positive numbers onto the stack. And then, oh no, how would you do it? I mean, you don't even need to store these into an array. I think it's as simple as like, if you find a negative number, look for the next positive number to pair it off with, and vice versa. There's like a toggle. That's kind of it. I think it's literally just left to right. Search. Yeah. Okay. That's actually like really easy. I think it's like a really easy question. I'm thinking about it. I could be wrong, but let me see. So, edge case nums is empty, or nums.size. Edge cases, we'll say. Well, it's not empty, right? We know it's not. We said that the test cases are such. We don't have to check that. All right. I don't think we need this vector either, by the way. So we'll do a loop over auto it equals nums.begin. It not equal to nums.end. Plus it. We'll say int x equals it, and y equals it plus 1. And we'll say diff y minus x, or is it y minus x or x minus y? I think it's y minus x. Yeah, y minus x. And then we'll say count if diff is greater than 0. We kind of have like a target, let's say. It could be 0, 1, 2, or 3. So the initial target will say 0. Say if target equals 0. This actually, we kind of want to use like an enum for this. I wonder if I could be fancy here and use some C++ enums. Gulp, because this is going to take me a lot longer. But this is better. Enum color, okay. So it's going to be enum. So we want like an inner class enum kind of a thing. So we're going to say enum. Yeah, enum. Oops. Not color, but target or expected. And we'll say positive, negative, either. Right? Red, green, blue. I actually prefer expected, positive, negative, either. And we're going to say expected target is going to be equal to either. Something like this, I don't know. And so we'll do a switch on these. target, case either, case positive, case negative, right? And we'll say if it's either, then we'll say if diff is greater than 0, then we're going to increment the count, and we're going to set the target equal to negative. If diff is less than 0, increment the count, target equals expected positive. Now, if it's 0, we just skip it altogether. If it's positive, then we say if, so the target is positive, diff is greater than 0, then we increment the count, and we set the target equal to negative. If we're expecting negative, increment the count, set that, now we're expecting positive. So we have this target, we have this difference, we have some logic here, update the state, so to speak, and then return count. Does that work? Does that make sense? Does that compile? Oh, it compiles. Okay, interesting. 5, expected 6. Looks like we're off by 1, so 511 should be 5110 should be 61210. Interesting. Really? Also, this was correct when I compiled this. That's kind of interesting too. I wasn't expecting that to be right. Not expecting that to be right. So, really? Okay, 1, so 6, -3, 5, -7, 3. So we saw 6. Target is either. And we said the diff is positive, so now the target is going to be negative. Okay, and then we would increment the iterator. And the difference would be -3 next. Target should be, so how come, so 1, 2, 3, 4, 5. Oh, I guess the count always starts off at 1. Yeah. Because, yeah, I think so. And that actually handles that edge case too. The reason is that the number of differences is not the same as the number of numbers in the set. So I think that's all. I think that's all you have to do. I think it's like really simple. I don't know, man. I'm just kind of trying some different things here. I don't know, man. Try a bunch of different stuff, throw some zeros in there. Wrong answer, nice. Which one is it? At the bottom, the 8. Okay, really, so this one at the bottom is wrong. Or doesn't, yeah, it doesn't. The bottom 3, interesting. 7, 7, 8. So why is that? Start throwing zeros in there, so it's really throwing things off. Oh, because we don't break. Probably. Excuse me. Yeah. I think we can go for it. Hey, you got there. Sweet, not bad. Yeah, I think it's a relatively easy question. I say that after spending 20 minutes on it. I don't know, it's just something like a state machine that I'm using here. I kind of like it doing it this way. I think there's probably a simpler way to do it, to write it, but I think it's simple enough. The logic is like, it's very easy to just kind of plop it on there. Can we run this a few times to get 0? There we go. There we go, 100%. Okay, sweet. All right, thank you for watching. I will talk to you soon. Have a, yeah, I'll just say that. I'm going to take a few moments and start another problem. So yeah, thanks for watching. Thank you. Thank you.